Welcome to the CoSpaceRobot family. Today, we will be introducing you to CoSpaceRobot Rescue. CoSpaceRobot is an official platform for both RoboCup Junior Rescue Simulation and RoboCup Asia-Pacific CoSpace Challenge. Please visit our website to find out more. In the CoSpace Rescue FirstSteps online challenge, participants have to develop and program appropriate strategies for a virtual autonomous robot to navigate and collect objects in a virtual world. The game will last for 5 minutes. The blue robot will be used to complete this challenge. The red robot will be removed. A team will gain points by collecting objects. Please refer to the slides for more details. For depositing one set of red, cyan, and blue objects at one go, you get 90 points. For depositing two sets of red, cyan, and blue objects at one go, you get 180 points. During the whole entire game, 3 relocations are allowed. The robot will be frozen for 10 seconds after each relocation. To successfully collect objects, the robot needs to use any one of the RGB sensors to detect the object. RGB stands for red, green, and blue. Stop for 3 seconds with LED flash. To successfully deposit objects, the robot needs to use both RGB sensors to detect the collection box. Stop for 3 seconds with LED on. After depositing, leave the deposit box automatically. For RCAP CoSpace Rescue FirstSteps, the system will divide the map into a 3x3 matrix with 9 sections. When the robot moves into each section, the robot's corresponding location information will be sent to the robot. This information can be used for planning purposes. The robot's current position on the screen is position x equals to 2 and position y equals to 0.
For optimal performance, your PC laptop should meet the minimum configuration. Let's watch a video guide on installation.
Hello, good job. We are almost there. Let's click on the Experience button to see if our computer is compatible with this software. While we are at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome. It seems that our computer is compatible and our software is up to date. And now it's time to activate our software. So there are 3 options: Learn, Compete, and Experience. So for this example, we're going to use FirstSteps. Right, we're going to click on Workshop Pack 1. The activation window has just popped out, so please make sure you're connected to the internet and input your account number as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code, there are no spaces in the front and at the back, because the serial code is case sensitive.
Double-click on the CoSpace auto-driving icon on your desktop. Now, choose the level and map, also known as the virtual environment. In this tutorial, we will choose the future city from FirstSteps for illustration. Frame rate, it is also called FPS, is a very important parameter. It will affect the robot performance if it is too low. You can check the frame rate on the status bar. It is highly recommended to keep the frame rate greater than 15 for robot smooth performance. If the frame rate is less than 15, you should change the display resolution to 1366 x 768. After changing the resolution, monitor the frame rate again. If the frame rate is still less than 15, you can change the rendering quality to low. The frame rate should be greater than 15 finally. To adjust the virtual environment, first, click anywhere in the virtual environment, and then, press the Q, W, E, A, S, D keys to adjust the 3D view. If you press Shift together with the keys, it will make the movement faster. If you mess up the environment, you need to click on the control panel and then click on Ctrl+H together to reset the virtual environment to the home position. To manually control the virtual robot, first, click anywhere on the control panel, and then, press the 4 arrow keys to move the virtual robot manually. As you know, there are IR sensors, ultrasonic sensors, RGB sensors and gyroscopes are installed on both real and virtual robot. While the robot is moving, the live sensor data will be shown on the control panel.
Let's start your first program. Launch CoSpace Rescue Simulator by double-clicking on the icon. Select the correct sub-league, content library, and competition map for the 𝐵𝑖𝑐𝗬𝒄𝒄 challenge. Programming a robot consists of 3 elements: sensing, planning, and action. Let's take a look at the CoSpace Rescue virtual robot. It contains the following sensors: 2 color sensors to sense the floor RGB color. RGB stands for red, green, and blue. 3 ultrasonic sensors to sense the obstacles on its front, left, and right. 1 compass sensor to sense the robot's orientation. For the robot's actuators, it contains 2 wheels and 1 LED for status indication. Participants have to plan and program strategies to control the robot so that it can collect more points. Click on the 3D environment. Click on the control panel and you will be able to control your robot using the direction keys on the computer keyboard. From the control panel, you will find live sensor data. If no program is loaded into the robot, you can use Minimap and keyboards to control the robot. When the program is running, all human operations such as pause, reset, Minimap, virtual joystick controller, and keyboards are disabled. What is the logic behind the robot's thinking process when it collects objects? The 2 color sensors mounted on the robot will let the robot know what kind of object is underneath it. And then the robot will take corresponding actions according to the sensor readings. So the first thing we need to do is to know the color of a particular spot on the map. We need to record the RGB readings of different objects. Red token's RGB reading is the collection box is orange in color. Sign color RGB reading is black color RGB reading is traps are surrounded by a yellow boundary. If the robot goes over the inner blue part of the trap, it will lose all the objects it is currently carrying, so be very careful. Double-click on the AI button to enter the programming interface. On the top of the programming interface, you will find some file management buttons. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. As you can see, there are many statements in one program. Conditions are inputs from the environment. The priority is set by statement order. The higher the statement, the higher the priority. Actions are outputs to control the robot. A good navigation program can help the robot complete a more efficient search. We will start from a basic navigation program with 4 statements. The first statement should tell the robot to move forward if there is no obstacle. The second statement should tell the robot to turn right if there is an obstacle on the left. The third statement should tell the robot to turn left if there is an obstacle on the right. The fourth statement should control the robot appropriately if there is an obstacle ahead. Statement forward. There is no obstacle, so we'll keep the conditions empty. In this scenario, the robot should move forward. Statement turn right. There's an obstacle on the left. Let's set the condition as ultrasonic left is smaller than 12, and let the robot turn right. Statement turn left. There's an obstacle on the right. Let's set the condition as ultrasonic right is smaller than 12, and let the robot turn left. Statement front. There's an obstacle ahead. Let's set the condition as ultrasonic front is smaller than 12, and let the robot turn right. Great! We have completed our first program. Once you have completed programming, it is very important to save and build. The blue robot will be used to complete this challenge. The red robot will be removed. Now you can click on the blue Build and Test Project button to see how the robot will behave. If you wish to modify the program, click on the Stop button and go back to the AI panel to modify the program. From our previous demonstration, we have learned how to navigate. Next, we'll learn how to collect objects with color sensors. At the beginning of the video, we have manually moved our virtual robot over red, cyan, black, yellow, and orange colors on the map, and we have recorded the corresponding RGB reading from the color sensor. Because the robot has 2 color sensors, we need to calibrate them separately with different colors. In artificial intelligence, search techniques are universal problem-solving methods and are a very important component of AI. CoSpaceRobot Rescue FirstSteps is designed to allow users with no prior programming knowledge to learn search techniques in a 3D environment from scratch. In the CoSpace Rescue FirstSteps online challenge, participants have to develop and program appropriate strategies for a virtual autonomous robot to navigate and collect objects in a virtual world. After the statement name is defined, we will add conditions and actions to these statements. To successfully collect objects, the robot needs to use any one of the RGB sensors to detect the object. Stop for 3 seconds with LED flash. Set key action, find objects. And set actions accordingly. Stop for 3 seconds with LED flash. Set key action, find objects. We'll set a range to include these values as conditions, and set actions accordingly. Stop for 3 seconds with LED flash. Set key action, find objects. We will now calibrate the left color sensor for black objects and set an appropriate action. We will now calibrate the right color sensor for black objects and set an appropriate action. We will now calibrate the left color sensor for cyan objects and set an appropriate action. We will now calibrate the right color sensor for cyan objects and set an appropriate action. Let's build and test a program. Awesome, your robot has been successfully calibrated. If the robot is on a white surface or a regular zone, the red object is worth 10 points, cyan object is worth 15 points, and the black object is worth 20 points. If the robot is on a blue surface or a special zone, the red object is worth 20 points, cyan object is worth 30 points, and the black object is worth 40 points. If the robot falls into a trap, all objects that have been collected but not yet deposited in the object collection box will disappear. When crafting a strategy, please pay attention to both offense and defense. Be balanced. Use the color sensors to avoid the yellow warning line. We'll set a range to include these values as conditions. And set actions accordingly. We'll set a range to include these values as conditions. And set actions accordingly. The maximum number of objects the robot can carry at any one time is 6, so we can only pick up more objects after we deposit them into the orange collection box. Use both RGB sensors to detect the collection box. Stop for 3 seconds with LED on. Deposit 1 means moving backward after depositing. Deposit 2 means moving forward after depositing. Use both RGB sensors to detect the collection box. We'll set a range to include these values as conditions. and set actions accordingly. In 𝐼Cool Challenge, you can load the DLL file and monitor the robot's performance in the control panel. When the program is running, all human operations, such as pause, reset, minimap, virtual joystick controller, keyboards are disabled. For every successful deposit, as a bonus, your points for that successful deposit will double. During the whole entire game, 3 relocations are allowed. The robot will be frozen for 10 seconds after each relocation. Second relocation. Third and final relocation. During a game, if you manually stop or pause the program, or if time is exhausted, the following dialog box will pop out. During the 𝐼Cool Challenge, you will need to save and submit the ICS file to the 𝐼Cool Challenge server.